In the previous video, we saw what are the peripheral devices and the importance of input-output organization. Now, in this video, we will see about what an input-output interface is. So, we have already seen that there is a mismatch between the speed of the CPU and the I/O devices. Okay, so to bridge this gap, we need special communication links or special circuit in between to match the match this mismatch of speed. So basically, the I/O means it provides a method. What is this I/O interface helps to? Then it provides a method for transferring information between internal storage, such as memory or CPU registers, and external devices. That is communication between the memory and CPU registers and the external I/O devices. We saw a lot of peripheral devices in the previous video. So we also know that the internal storage contains the CPU registers also, which is a temporary storage, and then you also have the memory. So the data may be stored either in CPU register or in the memory, and the data can be bidirectional. So it can either move the data can either move from memory or CPU register to the external device, which is an output to an output device, or the other way around. That is, from an input device, data can also move into CPU register or memory. So to provide a method for this transfer of information, we need what is called a I/O interface. In between the CPU and your I/O devices, in between them you have what is called as the I/O interface. Okay, so the purpose of this interface is because of the mismatch and because there are differences between the computer and the peripheral devices. So what are the differences? Peripheral devices are electromechanical or electromagnetic devices, whereas your CPU or memory is an electronic device. And then what is the data transfer rate? Peripherals is usually slower. I told you the the speed of an output device like an input device like a keyboard or an output device like your LED monitor, whatever it is, they are very slow. So the data transfer rate is very slow for peripherals, whereas the CPU or the memory, it is very fast. Okay, so we need a synchronization mechanism so that these mismatches is sorted out. Okay, then unit of information. So what is the unit of information? For peripherals, the unit of information is a byte. Byte means 8 bits. Whereas for CPU or memory, it is a word. So word length is, in those days, earlier, in the computer systems, I'm talking about 1970s and 60s and 70s and 80s and all that. Then the CPU also was CPU and memory was 8-bit systems. Okay, it was the word length was only 8 bits, which means a byte, almost equivalent to your peripheral. But then later on, as you see, you have from 8-bit it went on to 16-bit, and from 16-bit it went 16 bits, and from 16 bits to 32 bits, and nowadays we have even 128-bit length. The word size means 128 bits or even 64 bits. Okay, so what is the 64 bits, which means 4 byte 64 bits, 1 byte is equal to 8 bits. So in 64 you will have 8 bytes. So 8 bytes together is one word. So which means CPU at a time can read about 8 bytes together, whereas a peripheral can transfer only a single byte. So you can imagine the data, the mismatch. So a peripheral can transfer only 8 bits at a time, whereas the CPU, the word length will be, if it is a 64-bit processor, which means it can process 64 bits together. 64 bits means 8 bytes together. So 8 bytes at a time. So that is called as the word length. So unit of information, there is a difference in unit of information. And finally, the operating mode. So peripherals operate in autonomous and asynchronous mode. So what do you mean by autonomous? Autonomous means independent. So printer acts in the modus of operandi of a printer is entirely different from a monitor, from a card reader, from a magnetic tape, whatever it is. So the devices, the peripheral devices are the operating modes for the peripheral devices are independent. They are independent of each other and they are entirely different. Okay, that is why it is called as autonomous. And what is asynchronous? Asynchronous means which is not synchronous. Okay, so it because of the mismatch in speed, so it is asynchronous, whereas CPU or memory is synchronous. So these are some of the differences between the peripherals and the CPU or memory. So to resolve these differences we need what is called a IO interface. Okay, then so to resolve these differences between in the computer systems and the IO, a special software, sorry, a special hardware component between which is placed between the CPU and the devices to which will supervise and synchronize all IO transfer is called as interface units. So IO interface units. Okay. Now if you look at the block diagram here, so you have on one side you have the various peripherals. You have the keyboard, printer, magnetic disk, magnetic tape. So these are all the peripherals. And here you have the processor. So and this you have the IO bus. Now what is a bus? A bus is nothing but but it's a combination of wires. That's all. A bus is nothing but a group of wires. Okay. So this IO bus constitutes three different set of lines. So the first set of line is called as data lines, and then the second set of lines. So each one is a group. It is not a single line. Okay. So when I say data, here in the diagram they have shown only a single line, but it is not a single line. It is a bus separate. It is a bus on its own, which means data is not a single data. It's not a single line. It is a group of wires. Okay, it's a group of wires. That one single group is called as data bus. Then you have the IO, the address. So address is again a group of wires, address bus. And finally you have the control. So control lines or control wires, control bus. So these three together, the data, address and control together is called your IO bus. Okay. Now, so you will see that each peripheral contains an interface, and each interface is connected to all the three data, address and control lines of the IO bus. And these IO bus, the IO bus is also connected to the processor. So in between the processor and your peripherals, you have these interfaces. Okay, so each peripheral has an interface module associated with it. So what is the function of this interface? So the function of this interface is, now whenever there is an IO operation, whether it might be a read operation or a write operation, okay, whenever the processor comes across an IO instruction. So what is an IO instruction? You must have studied about these the instruction types in the previous chapters. Okay, so I am not going in detail into the instructions. So a typical IO instruction, how does it look like? It will contain an opcode, a device address, and a function code. Now, what is this? The opcode. You know what is an opcode? For each and for a write operation, you have one opcode. Like for mathematical operations, you must have studied. You must have learnt about add instruction, sub instruction, and all that. So these are and then whenever data has to be moved from one register to another register, or from one memory location to another register, whatever it is, you have a move instruction. So you have arithmetic operations, you have like that. So these instructions will be referred to by the opcode. And then you have the device address. Now, what is this device address? Now here you will see that all the peripherals, each peripheral has got an interface, and all these peripherals are connected to the processor through an interface. So whenever the processor places an IO instruction, so the particular peripheral has to be chosen. We have to determine whether the processor has to determine whether the IO instruction is for the printer, or whether it is for the magnetic disk, or for the magnetic tape, or for the keyboard. how do we distinguish between the peripherals? Okay, so for that each peripheral has got its own device address. Okay, each one has got its own address. So this the opcode along the opcode contains the device address, and you will see that the device address will be placed in the device address lines, and finally the last portion is called as the function code. So this function code will be placed in the, it's just a command. So the function code will tell what exactly the device, the peripheral device has to do. So this function code will be placed in the control lines. Okay. So now what will happen is you must have studied another circuit which is called as a decoder. A decoder circuit, each and every interface will have an address decoder. Okay, so I'm not going into the details of the address decoder because the decoder circuit you must have studied earlier. Okay, in the earlier chapter. So this decoder is nothing but a circuit which will identify, which will decode the address of each peripheral. Okay, so there will be a circuit which is called as a decoder circuit for each and every interface, which will when the address, when the device address is placed in the address line, then the decoder for each and every interface will will check the address to verify whether this particular the particular address is for the peripheral connected to to itself. So each and every interface has got an address decoder. Okay, so ஒவ்வொரு decoder will actually will take the check the address and check whether it is it is its device address which is placed here. So once when the particular device address is identified, then all the other interfaces will be disabled. Okay, let's say for say uh, what is the what is the function of this interface? So the first thing is it will decode the device address. Okay, I explained the process of decoding the device address to choose the particular peripheral. Then what does it do? I told you this function code will be placed in the control lines. Okay, so then it will decode the control. So what is the control? What is this function code? The function code will tell the printer to it may give some instruction to the printer, or it may give instruction to the tape, or it may give instruction to the magnetic disk, whatever it is. Some define the function code will vary according to the peripheral that it is addressing. Okay, so and the function code which is placed in the control lines will now be decoded. Okay, so each and every peripheral will have, there may be so many functions that each peripheral can perform. Okay, so for example, your in your printer you can say the printer to calibrate the printer and to adjust the printer, go to the next page, skip the first page and so on. Or if it's a magnetic tape, you can say rewind the tape, go to the beginning of the tape, or you can say go fast forward and go to the end of the tape, or you can place the tape in a particular position. So there may be, for each and every peripheral device, there may be so many functions. So to select the function, again there will be a decoder circuit. A decoder is nothing but a circuit which will select from different operations or different things that are available. So again there is a decoder circuit which will choose the corresponding function. Then after decoding that particular function, it will provide the function to the corresponding, it will provide signals to the corresponding peripheral. For every peripheral, there will be also be a peripheral controller. So this peripheral control, the interface will provide the function. It will give instruction, it will give the signals to the peripheral controller, and the peripheral controller will actually control it. It is a mechanical device which will actually control the peripheral. The peripheral controller will actually control the peripheral. So the CPU will place it will, once when the CPU comes across the IO instruction, it will select the device. The IO instruction will contain all this: opcode, device address, and function code. The device address will be placed in the address lines. The function code will be placed in the control. And each and every interface will, for every peripheral, there will be an interface, and each and every interface will have two decoders. One will be a device address decoder, and the other one to decode the control or the operations based on the function code. Okay, so the device address for each and every interface will check whether the address that is placed in the address bus is for itself. Once when a particular interface identifies the device, the address, then the rest of all the other interfaces will be disabled. Then that particular controller will enable now the connection, the link between the peripheral and the IO bus will be opened. Okay, the interface will now establish a communication, the link between the peripheral and the IO bus. Okay, there will be a connection, there will be a path between the peripheral and the IO bus. Then it will provide signal to the peripheral controller also. And finally, it will synchronize the data flow. As I told you, the path between the IO bus and the peripheral will be established, and it will synchronize the data flow between the either between the peripheral and the CPU or the memory. So this is in general the blocks diagram or the structure of an IO bus and interface modules. So interface detects its own address. As I told you, based with the decoder, it detects its own address and activates the path between the bus lines and the device and its controls. So the processor provides a function code in the control lines, and the interface selected will respond to the function code and executes it. Now, there are this function code is actually called as an IO command. There are four types of IO command. They are control, status, data output, data input. Okay, so the function, the opcode that I told you here, typical IO instruction. So this is what I am referring here. Okay, so there will be four types of IO command. One, it can be a control command, it can be a status command, or it can be a data output command, or it can be a data input command. So what is a control command? A control command is issued to activate the peripheral and inform it what to do. Okay, it is not a data transfer instruction. It is just a control command which just activates the printer. Okay, and not necessarily a printer. If the peripheral is a printer, it will activate the printer. Or as I told you earlier, if it's a tape, it can give a control command to move the tape, to rewind the tape, or to the fast forwarding the tape. So like that. So a control command is just to control the device. Then status. A status, as it and you know it is device independent. Whatever you do it for the printer, you cannot do it for the magnetic tape, and you cannot do the same thing to a magnetic disk. Or here you can even use your flash drive or your pen drive, whatever it is. Pen drive is also a pen drive is a disk. Okay, it's as a smaller version of your hard disk. It's again a magnetic, it's a device. Okay, so this these the commands are independent to it is device independent. They are different for each devices. Okay, so that is about your control. Now what is the status command? A status command is to check the status of the device. Suppose the data has to be transferred from CPU or from CPU to your output device. Okay, then it should check whether the CPU, the device, the source is your CPU and the destination is your monitor or a printer, whatever it is. So whether the printer is switched on or whether the printer is ready to accept the output from the CPU. So that is called the status, to check the status of the device, whether the status is the device is ready to accept the output. So so that is issued, that command is issued, it will using what is called as a status command. Okay, And the other function of the status is there are some bits which will refer to the status of the peripheral, and there are some bits which will indicate in the status command. There are some bits which will indicate the error. Okay, error in data transfer. Okay, there is something called parity, which is called even parity or odd parity. Okay, the parity means whenever a data is nothing but let's say 1 byte of data, so 8 bits. Whenever 8 bits of data is being transferred, this data can contain, okay, so let's say a character. Okay, each character is now 8. The length of each character is 8 bits. Okay, so like that, let's say we are transferring 10 characters. So each character contains 8 bits, and this 8 bits will be a combination of ones and zeros. Okay, so each 8 bits will now be appended with what is called as a parity bit. Okay, an odd parity or an even parity. If it's a even parity, it means the number of ones in the character is even. Otherwise, if it's an even parity, some it again depends on the system. So certain systems will follow odd parity, certain systems will follow even parity. So mostly it will be even parity only. So whenever the even parity bit is 1, it means the number of ones in the character, the number of ones in the character is even, otherwise it is odd. So just to check whether the data that is received is correct or wrong. So if when the even parity is set, where it says that the number of ones in the 8-bit data is even, but suppose if the number of ones is odd, it means the data that is transferred is wrong. There is some error in the data transfer. So just to identify the error, the if an error has occurred, then the status command will indicate that such an error has happened. Okay, so this is about status command. Now the data output command. So what is the data output command? It causes the interface to respond by transferring the data from the bus into one of its registers. So data output means from the CPU the data is now being transferred to a peripheral device, that is called as data output. So what does the data output command do? It causes the interface. Whenever a data output command is issued, the interface will respond by transferring the data from the bus into one of its registers. So here we saw the data is placed in the bus, and if the interface decodes that it is a data output command, then as I told you, a path will be established. So here the keyboard and display terminal, suppose if the display terminal is chosen, and if it's a data output command, then this interface will be chosen and the path will be established here, and the data that is available in the data lines will directly be transferred it will not be transferred directly to the monitor. Instead there will be some buffer here in between. We will be studying more about this buffers in later videos. So here in between there will be what is called as a buffer. So the data will be transferred into the buffer, and from the buffer the data will be this buffer now acts as a temporary storage for handling the mismatch between the speed of the processor and the peripheral device. So the data will be transferred and be stored temporarily in the buffers, and from the buffer the data will be directly sent to the output device. Okay, so that is what will happen when a data output command is issued. So an example is given here. So if the data output command is to output the data from the CPU to a magnetic tape. So what is the sequence of command? What actually happens? So a control command is issued first. So for moving the tape, a tape is nothing but, you can imagine a cassette. Okay, so we used to have cassettes in those days. So your magnetic tape is very similar to your cassette. Now suppose you want to record something in a cassette recorder, in a cassette tape. So what will you do? Suppose there are about few songs you have already recorded, and now you want to record some more. So you want to store something, some either a song or something you want to store in a magnetic tape. So what will you do now? So the tape has to be fast forward so that it goes to a. There are four songs in the tape. Okay, they are a serial. It's called a. It's a serial device. Serial device na one behind the tape will be. You can access the data one after the other only. You cannot access it directly, parallelly. It's a sequential. It's a sequential access. You can access the tape, the data in the tape only one after the other. So in a magnetic tape, so which means the tape has to be first positioned correctly for the data to be written in the tape. So that is the first command. The first one is the control command for moving the tape. Then the second one is the processor monitors. Once when the tape is moved, then the status command will, and the status will be set that the tape is now ready to accept the data. So the status command, a status will be set, and processor will monitor the status by issuing a status command. Then when the tape is in the right position, now the processor will issue the data output command. So what will happen? The interface now will respond to the address and command, and then transfer data from data lines to the buffer register. Okay, so then the interface communicates to tape controller. As I told you, each and every peripheral will have a peripheral controller, and the peripheral controller will now send the data from the buffer register to the tape, and store the data directly in the tape. So these are the sequence of operations that will happen when a data output command is issued. So what is a data input command? So data input command is exactly the opposite of a data output command. Now what is a data input command? So the data input is, yeah, so let's say a keyboard. So data is coming from the keyboard. So you have the keyboard here, and the data is coming from here in the opposite direction. Now the data has to go from keyboard to the processor. Okay, so what happens is interface receives an item of data from the device and places it in the buffer. So from whenever you press a key in the keyboard, the data, I told you for every key there is an ASCII value which is attached. So this ASCII value will be stored, a sequence of ASCII values will be stored in the buffer. In between there is a buffer, I told you. So the data will be now stored in the buffer. Then so it will, and then the processor will check whether the data is again, whether the status command will the status will be modified to tell the processor that data has been placed in the, some valid data has been placed in the buffer. So now the processor will keep checking whether the data has been placed in the status command, has been placed correctly. So once when the status says that the data has been placed in the buffer, what happens? Then the processor will issue a data input command, and then the interface will place the data in the data line. So the processor will issue a data input command, and already the data from the keyboard is placed in the buffer. So from the buffer, the interface will transfer the transfer the data to the data bus in the IO bus. So it will happen in the opposite direction. So that is a data input command. So this is about the IO interface. So we will see more about how the interior, how the what is an IO bus and what is a memory bus and all that in the next video.